Good morning, students. In the last class, we discussed about the effect of potential difference on photo current. So, in that, we observed two. That one is when we apply the positive potential to the anode plate, the electrons are emitted by the photosensitive material. Then it observes when it reaches for a particular potential, the current becomes the maximum. So that current we call as saturation current. So if we apply the negative potential for the plate A, that is collector plate A, then the amount of electrons which reaching the plate A is becomes very less, because high energy electrons only will reach the collector plate A. Hence, the current which flows on the circuit will reduces and it becomes to zero for a particular negative potential. So that potential we call as stopping potential, or we can call that one as cutoff potential or cutoff voltage. So by using these consideration, then in the last we studied that by changing the intensities of the radiations, that is keeping the frequency remains constant, we changes the intensity from I to I1 and then I1 to I2. Then we studied the potential which varied across the collector plate A, right? So by considering these as observations, we will discuss the effect of, that one is the third one, the effect of frequency on photo current. So this one is the third experimental observation. So in the third experimental observation, we will discuss the frequency of the incident radiation on photo current. So this one is frequency of incident radiation or light. Frequency of incident radiation on photo current. Right. So this is the potential. So that one here we connected the battery. That is potential. Right. So in the last discussion we discussed that here we kept the frequency and intensity remains constant. The radiations which falls onto the photosensitive material, the electrons are emitted. So here keeping this one in the positive. First we kept this one as the positive, then here the battery is positive and here it is negative. Right? So what happens here? As we increasing the potential to the collector plate, the number of electrons flow on the circuit is more. Hence, we get the current maximum. As we increasing the potential, we get the photo current, that is increased photo current. Right? When we apply the negative potential for this one, here also we have the electrons which stores, that is which is on the collector plate, and also the emitted one are the electrons. So both are the same charges, hence ripples will takes place between these two charges. Then only the energetic electrons will reach the collector plate. That is the less number of the electrons will reach the collector plate, and the current, which that is photo current, goes on decreasing and it becomes zero for a particular potential, right? So for that we kept the frequency and intensity as constant. In the last class we discussed that as we plot the graph for that one, that is photo current with respect to the potential. So along y-axis we taken photo current, right? So along x-axis we have collector plate potential. So here we have 0, and we here towards the left we taken retarding potential. So here we conducted two. So this one is the retarding potential V01. That is for the intensity I. So if we take similar one, then for that also we have the stopping potential is same, but the intensity, that is saturation current, is different. So this is, if we take this one as I1 and this is I2. For both the stopping potential is same. So this one as kept frequency as constant and varying the intensity. So varying intensity is I1, I2, like that, right? So in the third observation, that is the effect of frequency. Here what we are going to do is increasing the frequency, keeping the intensity constant for all the incident radiation, right? So here varying frequency. Varying frequency, we are going to study the photocurrent versus the potential difference. So as varying frequency is nothing but initially we given the value, the frequency nu1 for constant intensity, that is intensity taken constant, right? Only we are varying the frequency. For nu1 we studied when we given this plate positive potential, then electrons are emitted from this photosensitive material, then collected by the collector plate, and electrons will flow through the circuit. As we increasing the potential, the current also increasing. For a particular potential, the current becomes maximum. So that current is the saturation current, right? For nu1, we are studying the potential. First, we are applying the positive potential. Next, negative potential to the collector plate. Right? We are studying the potential difference versus, that is the accelerating potential versus the photocurrent. For first case, that is for frequency nu1, we are applying the positive potential to the plate A and we are applying the negative potential to the plate A. So here we are getting, one is saturation current and another one is cutoff voltage. That is, cutoff voltage is the potential. For a particular potential, the current through the circuit is 0. So that one is the stopping potential. So here we are getting, one is saturation current and another one is the stopping potential when we applied negative to the terminal, that is for the collector plate. So here we are getting the stopping potential. From this observation, right, for frequency nu1. Next, we are changing the frequency of the incident radiation, keeping the intensity as constant. That is, we are changing the frequency nu1 to nu2 and same procedure continuing. That is, first we are applying positive potential to the plate A, then we get the saturation current, and we are applying negative potential to the plate A for the frequency nu2, then we getting the same stopping potential. So here stopping potential can be taken as V01. V0 is represented by the stopping potential. So for frequency first, the stopping potential is V01. Next, for the frequency 2, we are getting the stopping potential that is V02. We keeping the intensity constant just by varying the frequency of the incident radiation. Nu1, nu2. So nu is represented by the frequency. Next, if we further vary the frequency, that is nu3, then we get one more stopping potential. So if you observe here, as frequency increasing, the stopping potential is also goes on increasing. So this one is for the stopping potential VO3, right? keeping the intensity constant, only varying the frequencies. We observe the photocurrent with respect to potential. As potential increasing, the photocurrent also varies for positive and also varies for the negative, right? So here if we plot the graph for this observation, for we get so this one is the curve which we get the potential current with respect to the collector plate and also the retarding potential. This is for the positive potential and negative potential. For which frequency we are getting? That is for the frequency nu1. So for frequency nu1 we getting this curve, right? So next we increasing the frequency, right? So from 1 to 3, that is we increasing the frequency of incident radiation, so we are getting the curves like this. So if I plot this again, right? So this one is minus V0 2, because it is negative x-axis, that's why we are representing minus, that is negative potential V01, V02, and for the third frequency, so this is for the frequency nu 2. So this blue color represents for the second frequency, that is nu 2. So if for the frequency nu 3, for this we get like this. So this is for nu 3 and here the potential is minus V03. So like this, we observe the potential as we vary the potential difference, we are getting the photo current, right? When we apply the positive potential, we are getting the maximum current. When we are applying the negative potential, we are getting zero current, that is negative potential. The current photo current is zero. We are getting the balance like this. As we increasing the frequencies, the stopping potential also goes on increasing. So this means that here, if you observe here, the saturation current for all the frequencies nu1, nu2, nu3. So for all the frequencies, this saturation current remains constant. So this gives the what saturation current. So for increasing frequency, we are getting the same saturation current. For example, if we given the frequency, for example, here it is 50 Hz, here 60 Hz, here it is 70 Hz. For 50 Hz, we are getting the saturation current I is equal to, for example, 10 microamperes. Then the saturation current for 60 also we are getting 10, and also for 70 also we are getting 10. So this means that as the increase in frequency, the stopping potential only increases, but the saturation current remains same for all the frequencies. So this means that the saturation current is independent of the frequency of the incident light. That is for varying frequency. So as frequency increases, we can write, that is here in these three, which one is greater than the frequency? That one is the nu 3 greater than nu 2 greater than nu 1, right? So here the frequency of nu 3 is greater. For that we get the greater negative potential. So if we write potential in the form V03 is greater than V02 greater than V01, right? But in this case, the saturation current for all these three are remains same, right? So by this, if I plot Here we are studying the frequency to the photocurrent. Then if I plot the curve for frequency, here this one is the frequency of incident radiation, that is nu. So nu is denoted for the frequency of the incident radiation. Along we take this one as along x-axis and photocurrent. Photocurrent along y-axis. So if we plot the graph for this one, as this means that as frequency increasing, the stopping potential also increasing. So stopping potential is nothing but it has larger values to stop the electrons which are coming from the photosensitive plate to the collector plate. That means that here, if positive potential is applied, then the electrons are emitted and it reaches the plate A. That is, here the energy which are getting by the photosensitive material, the energy is we call as from here to its traveling means this one is the kinetic energy. So the kinetic energy gained by the photoelectrons is reaches to the plate C. So it stops the stopping potential, that is the kinetic energy depends, the kinetic energy which depends on the frequency of the incident radiation, right? So the kinetic energy of the emitted electrons, so here the energy of the electrons depends on the frequency of the incident radiation. So if we have more negative potential energy, that is more negative stopping potential, then we have more frequency, right? So for example, this one value is more, that is frequency is more, and the electrons which are emitted from the photomaterial also the energy is more. To stop these electrons to reach this plate means we have to apply more potential, right? For applying the more potential only, then we can stop the electrons to reach this plate, then only the current flowing through this circuit becomes zero, right? That only we call as stopping potential. So the energy gain or the energy of the emitted electrons depends on the frequency of the incident radiation, depends on the frequency of the incident radiation. As frequency is more, then the stopping potential should be more. So this explains, right? So if we plot the graph for photocurrent to the frequency of incident radiation, then we get the curve like this. So this one is the frequency nu. So this one point we call as nu naught, right? So here what this curve represents, why this curve is not starts from the origin. Here we have values. So this one is the frequency, right? From, if we consider here it is 0, so the value starts from, for example, 10, 20, 30, 40, 50. So somewhere here, that is from 60, I am plotting this curve, that is linear curve. So this explains that the frequency which here, from here to here we have frequency, that is nu, right? So the frequency which is less than the frequency, this one is the cutoff frequency. So for the potential to stop, the minimum potential required to stop the electrons, then at that intensity, the minimum frequency, sorry, here we are using the frequency, right? So the minimum frequency we call as cutoff frequency. So this one we call as cutoff frequency or threshold frequency. Cutoff frequency or threshold frequency. Here simply, if you observe, negative potential we are applying here. The electrons are reaching to the plate when we apply the positive. when we apply the negative potential here, so this is positive and this is negative. So here we collected the negative electrons. So the electrons which are emitted from the photosensitive material are also the electrons. So here also electrons and here also we have electrons. So like charges, what happens? Repulse each other. Only few electrons that has maximum energy, that is which have maximum kinetic energy, that energy will only reach this plate, right? Hence for that the current flow through this circuit is reduces, and for a certain potential, if we increase, goes on increasing this negative potential here, this value becomes more, right? For that the current is zero, right? For this minimum potential, right? Here we are applying some minimum potential, that is V naught. For that the current is equals to, this instance the current is equals to 0. For this minimum potential we have certain frequency here. So that frequency is minimum frequency, that is nu naught. The potential which stops the flow of electrons in this circuit, that have some frequency which incident on this plate, that one we have the frequency. So below this frequency there will be no photo emission, right? So this frequency we call as cutoff frequency or threshold frequency, right? So from this here to here, from here to here we have lot of frequencies. So the frequency which between 0 to V naught, that is the frequency nu, which is less than the threshold frequency, then there will be no current flowing in this circuit. So that will be same from this graph, right? So understand this one, the frequency which is less than the threshold frequency or cutoff frequency, then there will be no current. So if you observe here, y-axis represents the current. For example, here we have 10 hertz, that is frequency 10 hertz, then is there any current flowing? No, because for 10 its value is 0, for 20 it is 0, for 30 it is 0, then for 40 it's slightly increasing. Next, for 50 we have current. So if you observe here, if I am not taking some 60 here, then we get current is some 10 microampere here, right? Similar way, if I plot for here, then I will get the current. But here in between 0 to nu naught, that is between 0 to cutoff frequency, there will be no current. So no current, nothing but there will be no flow of electrons. That means that there will be no emission of the electrons, right? So this one is the observation which we studied in this, that is frequency right. For photo emission, the frequency must be always greater than the threshold frequency. So below which the frequency, below the threshold frequency, there will be no photo emission, right? So for photo emission or photoelectric effect, we need minimum energy. For that minimum energy, we call that one, that is the kinetic energy. That the condition for the photo emission is the frequency must be greater than the threshold frequency, right? So this is the observation leading frequency to the photo current, right? So if we plot the graph for this one, frequency to the stopping potential, right? So taking stopping potential along y-axis and frequency along frequency of the incident radiation along x-axis. So here also we getting the same curve like this. So this one we call as nu naught, right? So here also we need minimum energy, as photocurrent is directly proportional to here. That is, the photocurrent linearly depends on the stopping potential. Then if the frequency which is less than the threshold frequency, then there is no flow of electrons. Then no flow of electrons is nothing but the stopping potential is 0. Right? So this is the curve for the stopping potential to that of the frequency. Right? So next, here one more we discussed, that is the energy of the emitted electrons is proportional to that of the applied stopping potential. That is, the energy gained or emitted by the electrons, that one is energy, kinetic energy or kinetic energy of the emitted electron, that is equals to electrons emitted to the stopping potential. Right? So stopping potential gives the significance of the emitted electrons, that is kinetic energy of the electrons which are emitted. So this one is the significance of the stopping potential. So it gives the significance that the energy of the emitted electrons is proportional to that of the stopping potential. Right? So if the energy is more, then the stopping potential is also more. So if the frequency is more, then also the stopping potential is also more. Right? So these are the observations, that is experimental observations of frequency of the incident radiation to, that is on photo current. Right? So this one is the third one. Next and the last, the effect of the materials, photosensitive materials. So next, fourth one is effect of photosensitive substance or materials on photo current. So different materials, different photosensitive materials exhibit different nature to that of the light. Right? So in that we have only two cases we are going to study. That is, one is different photosensitive substances exhibits differently on the, that is the materials which respond differently on the light. So for a particular light, so each substance will react, that is each substance will respond differently. So in that first one, if you study, means the photosensitive substance, that is different photosensitive substance or material or surfaces which that is reacts or which difference with the different nature. Right? So differently with light, that is different photosensitive material or substance respond differently with light. So this one is the first point. So different photosensitive materials respond differently with the light. For example, we considered one, that is